All right, I would argue that among maybe the crafting system and having like those buttons driven by a data table, this whole metadata thing is the reason that I would call this a intermediate to maybe, if you want to be fancy, slightly advanced inventory follow-up course. And that is because it's gonna be a little bit tricky to get into, but we're gonna go through this one step at a time. So what is metadata for the people who might not know? Metadata is data about data. So in this case, our items are the data and our metadata will be data about those items. So for instance, for a sword, you might have a durability on your weapon. That would be considered metadata. You might have enchantments on your sword. Think about Minecraft. That would be metadata. You could argue that things like the stack size technically could be considered as metadata as well, but since every single slot in our inventory system is going to need to have a stack size to work with anyway, that's just part of the basic inventory slot structure, and we didn't make that as like a separate thing of metadata. Today we're going to be constructing specific metadata objects, and that's going to be a little over-engineered at first, but it will be a more scalable and more manageable way to deal with things as your game grows. So let's just get started with that. We're going to go right into our content folder here. I'm not going to open up anything because we're going to be opening up things when we get to it. And we'll make a new blueprint class. And something that a lot of people actually overlook, including me for the longest time, is that you have these common ones and then you have all classes. Everybody knows that, right? Everything inherits from objects, but people kind of overlook the fact that you can also make your own basic U object. It's called a U object, technically speaking, but just your own basic object. That doesn't need to be any of these other things. So that's what we're going to be doing here today, and this will just be our BP metadata. This is not going to be an actor. This is not even technically like an asset. This is just a... The only thing that really makes this special in any way is that it is a U object, meaning that Unreal's garbage collection system is going to be able to deal with it. And we'll talk a little bit more about the garbage collection system because you do need to be a little bit mindful with how that works. Since Unreal collects garbage, unused objects, deleted objects by itself, you don't have to do that manually, which is really nice, but you do need to be careful that it doesn't garbage collect this out from under you. In C++, that is a little bit easier to manage because you have more of like fine-grained control over that, but for now, we're just going to deal with that when we come to it. For testing purposes, I'm going to open up this metadata, and you will note that there's actually not that much going on. We don't even have like a begin play, or we don't even have a tick, I don't think, because that is something that exists in the actor itself. Like this has no pre-existing event. This is entirely empty. So we'll only put in a counter or something like that, just for testing purposes. We'll make that an integer, so that we have some metadata to write to and to read from for testing our system. The idea being that if you need specific metadata for a specific type of item, you're going to make a child class off of this broad metadata class, which will then allow you to cast to that and get the specific information out of it. Like if a sword has metadata, it can have like a damage boost metadata or an enchantment metadata bit or a durability, but a shield will probably have entirely different metadata. So what you'll do is when you know that you're working with a sword in your code, you will cast the metadata to the sword metadata class. And if you know that you're going to be working with something like a shield or a helmet or maybe a key, for instance, if you have a key object and you assign metadata to it, you can say, oh, this key specifically links to a specific door. If you know in your code that you're working with a key, the door will be checking for a key item in your inventory. Then it can cast the metadata object on that key to the key metadata object and check, hey, does this key's metadata point specifically to me? Does it allow it to open this specific door? If that doesn't make full sense yet, don't worry about it. We'll just construct this entire thing and it will start making sense eventually. So there's a couple of old places that we're going to go back to add some things about metadata here. And the most important of which is the BP item class itself. We're going to assign every item a metadata class as well. So we'll add a new variable to this and call this metadata class. and that will be of the type metadata, and you'll need to look through here. We have the BP metadata, and will be a class reference, and of course we're going to be exposing that as well. And the default value of this can just be the BP metadata for now. Then we want to open up our inventory components, and we're going to go into the add item function. When we add a new item to a slot, to an empty slot, a new item is getting created. That's where we're going to be constructing our metadata. Because if we already have a slot that is filled with something, we don't need to reconstruct the metadata. We only increase the stack size of the thing that already has metadata on it. This can cause some issues and some conflicts with merging stacks together if the stacks don't have matching metadata. We can take a look into that in a moment. We can set up an interface that checks whether or not two metadata objects have the exact same data in them, and if so, it will allow the merge. If not, it will not allow the merge. We might make a separate video about that after this one though. For now, when we make the new item, we set the new array element. We're going to make a little bit of room here in the blueprint graph for that. What we'll do is we will construct a new object from class. Be aware that that is not a spawn actor from class that spawns specific actors. This just constructs a object, which is different. And the class that we're going to be constructing, and this is actually quite nice, is going to be the class of the item asset. So we can get the metadata class, and you can dynamically say what type of object you're going to be constructing. So if you say, hey, an item asset for a sword has the metadata class assigned to it for sword metadata, this is going to be constructing a sword metadata object. This is a mistake that I made while initially developing this system, and it's a mistake that I made in the video itself again. You don't want to get the item asset from the breaking of the for each loop. What you want to do is you want to get the item to add and get the class from that one instead. Because obviously the slot that we're trying to place the item into doesn't yet exist. Now, we get to a little bit of a tricky, fucked up little bit, and that is that a object, when constructed, needs to have an outer. And if you hover over it, it says it's the owner of the constructed object. Every object in the game is going to have an owner, something that it belongs to. And you might think, oh, we'll just set that to the inventory that we created in. But that, while it doesn't really matter, it can be kind of tricky to deal with, because once it is set on creation, you can't then afterwards change it. You can reset the outer. The way you would do that is create an entirely new metadata object and assign all the same values to it with a new outer. And that is a little bothersome to deal with. So the easier way to deal with that is just to assign every bit of metadata for every item in your game when it gets constructed just to something that is going to be persistent anyway. So we'll say get player character, because the issue is when the owner of an object disappears, everything that it owns also disappears. So if you set this to a inventory component on a chest, for instance, you take something out of the chest and then you walk away and the chest unloads, suddenly the outer object for your metadata is gone, which means that your item is broken now. So you need this to be something persistent, and your player character is always going to be around. Alternatively, you could do the player controller instead, or even the game mode, or maybe even the game instance. Or you can overcomplicate things and make like entire functions to reconstruct new metadata items when they change inventories and that kind of stuff. Frankly, this whole metadata thing could be a sub-series in and of itself. We're just going to assign it to the player character because, frankly, it just kind of works well enough that way. Once it is constructed, what we need to do is we need to set it to the inventory slot as well. So that means that we're going to go into our inventory slot structure. And there will also add a new variable for the metadata, which will be of type BP metadata, obviously. And this is going to be an object reference, not a class reference like we did before. And now that is a slot that we have in here. This is the annoying bit, because now that we've added something to our inventory slot struct, anytime that we're copying over one inventory slot to another inventory slot, we're going to need to go through and copy over the metadata as well. That is partly because we frankly kind of set up a few of those moments a little bit poorly. Could have set that up a little bit more optimized and a little bit more flexible, but that's the world we live in now, so we're going to have to deal with that. And it's also partly just something that we have to do. And then coming up here too, if we're adding items to a item that already exists, we're making this slot and setting array item. I'm trying to do away with the set array elements node where I can. So what we'll do instead is we will get a reference to the index. You can see here, there's the array index. And instead what we'll do is we'll set a member. And the only member that we'll be setting here is the stack size, because that's the only thing that's going to be changing. And the rest of it will be left alone, because otherwise we'd need to like plug in the metadata here as well, and then the items add and all that kind of stuff. And none of that is really necessary, because that's all going to remain the same no matter what. So we can just hook this up into true and then going on and move on with our lives. The only really like big place that we need to worry about that, I think, is in the inventory screen in the item slot itself. That is where we're doing a lot of copying over in the on preview mouse button down, as you can see. So we have, let's just go from top to bottom. Like in some places here, we are making new inventory slots from the existing inventory slots. And if we're just copying over the entire inventory slot into like a temporary holding inventory slot like this, that's not a problem. It's just going to be copying it over. But it's these situations that become a little bit annoying. So because we're taking some of the data from one place and some of the data from the other place, we now need to go over all of these and connect up the proper metadata. So in this case, we're going to be getting the drag drop item slots metadata and putting that into the new one. And then down here, we have the same thing. So again, we have a drag drop item slots and we want to get the metadata from that one. And all the way down here, I think we also do something similar. So we want to set the metadata for both of these make nodes, which are a little bit messy, to be the metadata from the inventory slot itself. And those should be the most important places that we deal with metadata transference between slots. The only other real important place that we deal with that is in the inventory component itself, in the merge stacks. And as I mentioned before, you really want to like check the different stacks here, their metadata, whether or not they match to begin with, because if they don't, you don't want to allow the merging of stacks at all. But that requires a little bit of reworking. So for now, we're going to skip over that, and likely in the next video, we're going to come back to cleaning up some of this metadata stuff. I don't want these metadata videos to be too long because I feel like this is going to be a little bit more complicated than most things as far as metadata goes. So in the function that we have here, we already are setting local variables, so we can just promote the metadata for the target. So this will be target metadata, and we will set that, and we'll add a rerouting node just to make it look good. It's on the bottom. It should really be there, but I can't be bothered right now. And then for this one, might as well do this one properly. We promote this one to a local variable, and this will be the source metadata. And again, we can just make a blueprint interface on one of these to check whether or not it matches the data on the other one. We'll do that later. And then in here, we have a couple of places where we need to like assign some metadata stuff. So if we merge the stacks, we're getting the source metadata and setting that into here. And then the source slots will be set to being entirely empty, so have empty metadata as well. Fill stack and return remainder is the other branch that we have here, in which case we want to supply it back with the target metadata instead. But then the source slots is going to need to be given the source metadata back again as well, which again, I'm not really explaining and going over all this in detail because I think we should rework this anyway. The thing is, you don't really need to split up the metadata and check it against each other, because this entire merging thing should only be able to happen if these two are like exactly identical anyway, right? So you really only need to save one of them and just apply that back into both. Or if they are different, not allow any of this to happen. And also we have like a lot of old code here that we don't need to have there anymore. And then we can go on into subtract item. And this is kind of the thing that I was talking about. We didn't set this up fairly well because we're setting the entire array element here. And what we should definitely be doing instead is we should be getting a reference to this index instead. And that just set the members in that slot. And then has item will just manually set to true. The stack size we will get from this value over here. The item assets we'll get from this value over here. The index we will get from this value over here. And then we can just leave the metadata alone. Like the set array element thing forces you to resupply all of the information that exists already. But we don't need to do that. Matter of fact, I think we're just copying over some values here that don't change. Like the item asset, right? We don't actually need to change that, so we can just get rid of that. The index also remains the same. We don't actually need to change that. Has item, also don't need to change that here. We only need to adjust the stack size here. So this is a lot more straightforward doing it this way. And it doesn't create this weird ass stuff where we need to resupply stuff every time we add new information to our struct. Same thing here in the add item to stack function. I'm just going through all the functions and seeing where we have issues. We use this set array element. What we can do instead is we can just use the get reference, provide in the stack index and say set members. And the only member that we need to change here again will be the stack size. So we'll just update the stack size like this. And we can get rid of all this stuff and not need to worry about all this and the metadata to go with it. Actually, we do need to use this getting node as well. But we don't need to worry about this. And that makes our entire code just a lot more actually user-friendly. So connect everything back up here, put item in new stack. I guess this one can keep being the way it is, that is fine. Split stacks I don't think works right now very well. And that is because we have this slot index that we're getting. I guess here, because we're splitting stacks, both of them are going to have the same metadata anyway. So anywhere we have a make node, we just provide in the metadata from the breaking node. That's just quite easy that way. Of course, in the inventory constructor itself, we don't need to provide in metadata because this just makes an empty inventory. Swap slots deals with entire slots and not broken down slots. So that's actually fairly easy. Clear inventory slot obviously just clears an inventory slot, only keeping the index around, so that makes sense. And that's everything that is to do with metadata. So we now have this stuff all set up to work, and the system is updated to deal with metadata. Now let's actually show you how that works and that it works and all that good stuff. So first and foremost, we cannot do this anymore, where we have an inventory component that just has like pre-existing items on it, because these won't have metadata created for them, which is a little bit annoying. So if we go into the inventory component here and we go into the construct inventory, we can still do this. We just need to save this inventory component that we had to begin with, promote it to a local variable. This will be the storage before it actually gets cleared out into being entirely empty. And then after we've constructed the entire inventory altogether, we'll do another for each loop, and that will just go over the temporary storage of the inventory. And there we can just simply like break inventory, and we will just check, hey, any items that were in the inventory before, let's re-add them. So we add item, and the item to add will be the item that we have in there. And we will, of course, do that in a normal for loop. We go from 1 to the stack size. And that will then re-add the items that we put in there in the editor, but now with metadata. And of course, you do want to construct that inventory before you create the widget, because the widget is going to be taking in the constructed inventory. And now we'll be able to see that if we open up this chest, it has the 40 rocks in it that we had in there always, but not in 2 stacks of 20, because rocks only are allowed to stack up to 10. So it's actually adding them in the way that they should be added in, so they don't have any like stacking overflow type of stuff going on anymore. So now everything works fine. Now the last place that we probably need to change this metadata thing is in the inventory grid here, and that is in our update item grid. When we create a new widget blueprint, you can see that it's created with a empty metadata slot, so that's going to get rid of the metadata. Once we have hooked that up, we can test things out properly. And the way we can test all that stuff out is going into our game and then putting in a console command, and that console command will look something like this. obj list class equals the name of your metadata object dot the name of your metadata object underscore c. The underscore c is just a quirky blueprint thing. And if you run that, you will see in total we have 5 objects now. And that adds up because we have 4 stacks in here. And I also gave myself some rocks, apparently, on startup. And then if we pick up some more items here, that's 2 more, that's 3, that's 4 more. But those are the same items, so there's only 3 more. So if you run it again, we should see 8 objects now. Now, back in our character here, I'm going to add a debug key. I think we still have a debug key left over from our crafting system, which we don't need anymore. And we're going to, when we press the debug key F, we're going to collect garbage. This is just going to force Unreal's garbage collection to run so that we can see whether or not objects are getting garbage collected or not. And then if we press that garbage collection key that we just set up, so F, and we run it again, we still have... Now, there still is a couple of issues with this entire thing, that being if we split these things up, it doesn't actually make new metadata objects, it just shares the same metadata object. And this is coming down to how references or pointers actually work. When we're splitting things up, we're just setting both of these stacks to reference back to the same metadata object, rather than creating a new one for the newly created stack. So we can see this will still be just 5, even though we have very clearly like 9 different stacks here. And then we can like merge them back together and stuff like that, and it'll always still be fine. So there's a little bit more work to do on this metadata thing, but I think that this video is long enough and large enough as it is. So we have created these metadata objects now, and we have them persisting around, being prevented from being garbage collected when we don't want them to. Obviously, if we end up like deleting any of these items, they won't be referenced any longer, and if we garbage collect them, they will be removed. Which actually brings me to this button. I haven't updated that to use our new system yet, so we just created a mouse button down, and we just get the player character, cast that to our class, get the drag drop item slot variable there, we remove that, and then we set it to null, and that'll just remove the item for us. So now we have a couple more things in our inventory, and I can drag and drop these and remove them. And now if I garbage collect and I run this again, we see we only have 3 objects left, because when the items actually get deleted, the metadata objects are no longer referenced by anything because they're only referenced by the inventory slots that they exist in. So garbage collection can grab them and reallocate that memory. Next time we'll fix up a couple of the issues about this, like the splitting and the merging of stacks, and that's going to introduce us to also allowing to read and write from these metadata objects. It's quite an undertaking to set up this metadata, but it is really quite cool. So tune back in then, and for now, hopefully this was kind of manageable to make. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sir J. Thomas,